In 2025, the impact of people spreads deep into areas once considered remote. Trails that once saw modest traffic now host millions of visitors each year, particularly in the Adirondack Park. Over the past decade, recorded hiking pressure there has nearly doubled. Forest paths that could once recover after a busy season now show exposed roots and wide erosion scars that don't heal between summers. This kind of strain adds up over time. Soil in heavily visited spots becomes compacted under constant foot traffic, pressing the ground into hard surfaces where new plants can't take hold. Instead of a living forest floor, repeated steps grind soil into packed dirt. When rain comes, water runs over the surface instead of soaking in, washing away what little loose soil is left. Recovery slows, plants vanish, and the terrain takes on a new, worn-out look that isn't entirely natural. Researchers now warn that human impact can rival some effects of climate change in these reserves. More visitors mean heavier pressure on fragile land that evolved without this constant attention. Even in the wildest parts of New York, people are reshaping geography just by being present in such large numbers. Fresh wilderness protection wins. Fact 33. Even as cities keep stretching outward, New York has made a major move in the opposite direction. In 2025, the state added new wilderness areas into its Forever Wild protections, expanding the sections of land that must remain free from development. These aren't small parcels hidden away on a map. They include wetlands, forest corridors, and stretches of land that physically link the Adirondacks with wildlife ranges in Vermont. The idea is simple: build natural bridges that animals can use to move between regions without running into highways and neighborhoods. The wetlands, in particular, hold real importance. When heavy rains hit, they absorb overflow and store it like sponges, releasing water slowly afterward. This prevents floods and stabilizes watersheds downstream. At the same time, these restored marshes serve as rare nesting grounds for species that had struggled as old habitats disappeared. Protecting these ecosystems means protecting every layer of geography around them. By locking down more land under this status, New York is layering insurance into its own geography. Natural buffers reduce flooding, forests act as long-term carbon storage, and corridors hold together ecosystems under pressure from climate extremes. The payoff is clear. Wilderness protection ensures that at least some parts of New York's landscape will remain untouched for centuries to come. Fracking's lingering scar. Fact 32. Even though hydraulic fracturing, or fracking, is banned in New York State, the land in the southern tier still carries the signature of early exploration. Decades ago, test wells were drilled into shale formations to gauge potential gas reserves. Those trials didn't result in widespread production, but they left behind subtle geological scars. In 2025, new surveys reveal that the underground record of those activities is still visible. One of the clearest examples is seismic activity. Small earthquake clusters, often too weak to cause damage, have been documented near past drilling sites. These tremors are not random. They trace back to shifts along fault lines disturbed during earlier exploration. The Earth in these areas moves slightly more than expected, and modern sensors continue to track the difference. Water chemistry has also changed. Some aquifers in the southern tier show shifts that researchers connect to testing that happened decades ago. Elevated mineral content and altered flow patterns hint at disruptions between rock layers that were once sealed. Even without current drilling, those marks remain etched into the region. Communities near these sites have grown cautious. Residents know the statewide ban prevents new drilling, but the ground they live on still demands monitoring. In 2025, New York proves that outlawed practices can still leave geological signatures that last for generations. The vanishing empire farmland. Fact 31. Farmland once stretched across huge portions of New York, but by 2025, those open fields are shrinking at a steady and measurable pace. Updated state data shows that every year, thousands of acres of arable land vanish under new roofs, roads, and shopping centers. What was once cropland is now more likely to be carved into subdivisions or commercial strips. The shift is so consistent, that entire regions are watching their farming identity fade almost season by season. One of the hardest hit areas is the Hudson Valley. The same qualities that made it prime farmland, rich soils, gentle terrain, and proximity to New York City are also what drive development pressure. Housing demand has transformed acres of productive fields into neighborhoods, leaving farmers with fewer places to plant. In counties closest to the city, it's common to see barns and silos standing next to brand new housing tracts, physical reminders of how quickly the transition happens. The consequences ripple far beyond local harvests. As open land disappears, so does the traditional scenery that defined much of upstate geography. The long belts of farmland once stretching between small towns are now broken into scattered fragments, edged by asphalt and concrete. New York's landscape in 2025 looks less like farm country and more like extended suburbia, reshaping the map at a record pace. Hudson Valley's ancient rocks updated. Fact 30. The Hudson Valley may look like nothing more than rolling farmland and quiet towns, but new studies in 2025 show it hides one of the most complex geological stories in the Northeast. Geologists tested new bedrock samples pulled from deep beneath the valley and found layers far older than what had been charted before. These rocks contain fossil traces and mineral signatures dating back to periods when most of the region was thought to be geologically younger. This evidence changes the valley's position on scientific maps and forces researchers to rethink its past. What makes this discovery stand out is how the Hudson Valley formed. Instead of being a simple river basin, scientists now understand it was once a dynamic rift zone. Hundreds of millions of years ago, the crust here stretched and fractured, much like the early stages of an ocean opening. The new rock signatures confirm that tectonic forces tore this region apart, leaving scars buried under fertile soils. That activity places the Hudson Valley alongside global examples of continental breakup, not just regional erosion. Hidden beneath today's farmland is the record of immense tectonic events, some comparable to the opening of the Atlantic itself. In 2025, the Hudson Valley proves it is far older and far stranger than its peaceful scenery suggests. Adirondack acid rain recovery. Fact 29. For much of the late 20th century, acid rain was one of the greatest threats to the Adirondacks. Sulfur and nitrogen compounds carried on the wind fell into the region's lakes and forests, lowering pH and stripping the land of its capacity to support life. Entire lakes, once considered prime fishing grounds, became sterile bowls of clear water, empty of trout and bass. Forests surrounding these lakes bore scars of the same process. Needles yellowed, soils grew too acidic for seedlings, and certain tree species struggled to regenerate. By 2025, new environmental reports reveal signs of recovery that would have seemed impossible 4 decades ago. Regulations curbing smokestack emissions across the Midwest and Northeast cut the pollutants that fueled acid rain. As a result, soil chemistry in the highlands has begun to normalize, and water testing shows pH levels gradually shifting into ranges that once supported healthy fish populations. Trout have now reappeared in lakes that were written off as dead, their return seen as a measure of ecosystem balance coming back. Forests tell a similar story. Stands once thinned by acid damage are growing more vigorously along recovery corridors. Red spruce and sugar maples that had struggled through the harshest years are regaining strength. The Adirondacks now show that even widespread damage can, given time, be reversed. Geology's endangered list. Fact 28. Most people know New York protects its rare plants and animals, but fewer realize the state also keeps track of endangered geological sites. These are formations and landscapes that can't simply grow back if they disappear. In 2025, the state's list highlights places at risk from both natural erosion and human activity, with caves, glacial deposits, and mineral outcrops topping the concerns. Many limestone caves across upstate New York now show signs of collapse as groundwater slowly dissolves their walls. Once open chambers and passageways begin to weaken, parts of them close forever. At the same time, some of the state's iconic glacial formations, like kettle ponds and drumlins, are eroding faster than expected. Farms, roads, and changing rainfall patterns strip away the soil that once preserved their distinctive shapes. Mineral beds, many of them containing rare crystals and unique rock layers, have also been marked at risk. Collectors, curiosity seekers, and in some cases vandals remove pieces that will never return. Tourism adds fuel to these pressures. Trampling feet, unauthorized digging, and general wear all speed up the destruction of fragile locations. Conservationists now argue it's time for a legal framework to protect geological sites the same way biodiversity is protected. Landscapes, like wildlife, can vanish forever if not safeguarded. NYC rivers beneath the streets. Fact 27. Few people walking the streets of Manhattan or Brooklyn realize that rivers still run beneath their feet. Centuries ago, the city was crisscrossed with streams, marshes, and brooks that guided early settlement. Most of them were buried as the grid expanded, covered over by pavement, buildings, and sewers. By the 20th century, their paths had all but disappeared from memory. But in 2025, new mapping projects have confirmed that many of those channels still flow underground, quietly moving water through hidden networks. Survey teams using ground-penetrating radar detected fresh subterranean routes weaving beneath the financial district, parts of Midtown, and sections of Brooklyn that once held tidal creeks. In some zones, water pressure is so strong it forces its way back to the surface during heavy storms, explaining sudden street floods that don't match rainfall totals. Builders working on modern tunnels sometimes break into these lost streams by accident, facing bursts of groundwater strong enough to delay entire projects. Geologists are now redrawing forgotten river maps, piecing together pathways last noted in colonial records. These underground flows keep running whether city life notices them or not. In effect, New York City carries a hidden set of rivers beneath its concrete, veins that continue to shape the land from below. Staten Island's changing edge. Fact 26. Staten Island is where the ocean's advance is easiest to see inside New York City. Surveys completed in 2025 show that its shoreline is shrinking at a pace unmatched by the other boroughs. Marshes that once absorbed high tides are now overwhelmed on a regular basis, leaving less of a buffer each season. What used to be occasional flooding has become almost routine, as tide lines push farther inland and saltwater cuts across low-lying ground. These shifts are not only visible in natural areas. Entire neighborhoods, developed decades ago with the assumption of stable land, are reassessing their future. Some residents now live with water brushing the edges of streets that weren't even mapped in flood zones a generation ago. Local officials continue to study sea-wall designs and other forms of protection, but questions remain about how long these measures can hold back the pressure. Each option comes with staggering costs, and every year of delay means more ground is lost. Out of all 5 boroughs, Staten Island stands as the clearest example of where urban geography meets relentless coastal erosion. For its communities, the disappearing edge is not distant science, it is daily reality. In 2025, this changing shoreline makes the borough a living case study of land loss. Thousand Islands mystery. Fact 25. The Thousand Islands look like nothing more than scattered dots of land breaking the surface of the St. Lawrence River. In 2025, however, new geological mapping revealed that these islands are far from random. Researchers found they are the exposed peaks of an ancient mountain ridge, cut apart and submerged by glacial forces. Rather than small fragments, each island connects to a much larger structure that once stretched across the region like a solid wall of rock. The discovery came from detailed studies of their bedrock. Samples collected on several islands match stone formations found more than 1,000 kilometers north, deep in Canada's Precambrian Shield. Those rocks are over 1 billion years old, meaning the same ancient crust that underpins Canada is also exposed in this river archipelago. The glaciers of the last ice age carved through this ridge, drowning parts of it and leaving the high points above water. What appears today as an island chain is really the eroded top of an ancient mountain system. This reclassification changes how scientists view the St. Lawrence landscape. Instead of small river islets, The Thousand Islands are now recognized as a fractured remnant of one of Earth's oldest mountain belts, quietly resurfacing in New York waters. Beavers as land architects. Fact 24. Beavers are more than just animals living in the backwoods. They are in many ways engineers of the land. In 2025, population reports show their return across the Adirondacks, and Catskills is not just steady but influential. Colonies have grown to sizes large enough that their building activity is altering waterways on a wide scale. The dams they construct look simple, but each one shifts how rivers, streams, and valleys function. When a beaver cuts trees and piles them into a barrier, the result is a pond where clear-running creek once flowed. These ponds spread water out, slow currents, and create wetlands that did not exist just 2 decades ago. In storm seasons, they serve as natural breaks, holding back sudden runoff that would otherwise race downstream. The effect is visible across multiple watersheds, less flash flooding and slower erosion of stream banks. The new wetlands enrich biodiversity too. Amphibians, fish, and birds all move into the stable ponds built behind the dams. Trees along the edges also benefit from consistent moisture once absent. Researchers now consider the beaver one of the most effective natural shapers of land in New York. In 2025, a single species demonstrates how animal behavior can transform geography. Tapping into Earth's heat. Fact 23. When most people think about geothermal energy in the United States, they picture the hot landscapes of Nevada or California. But new tests in 2025 have revealed something surprising beneath New York's surface. Deep under the Adirondacks and Catskills are layers of rock, storing much more heat than anyone expected. These rocks have held energy for millions of years, pushed upward as old mountains formed, and they may one day be tapped to power entire towns. The measurements show temperature gradients high enough to compete with well-known geothermal regions out west. At certain depths, the rock is naturally hot enough to generate steam strong enough to run turbines. This potential changes the way scientists look at New York's underground. Instead of seeing only old granite or metamorphic layers, they now recognize a reserve of energy locked away inside them. The biggest barrier is distance. To reach these hot rock layers, wells would need to be drilled miles below the surface, far deeper than most conventional drilling projects ever go. At present, the cost and equipment make it difficult, but advancements in drilling technology are already reducing those challenges. Beneath New York's bedrock lies a power source older than its mountains, waiting for the right tools to access it. Volcanic traces still visible. Fact 22. The Hudson Highlands don't look like volcano country. The hills are green, the trails are popular, and the bedrock shows nothing dramatic at first glance. But new geological updates from 2025 reveal that beneath the surface, the story is very different. Rock samples once labeled as ordinary tectonic remnants now show clear volcanic minerals embedded within them. These aren't random traces, they point to an eruptive past that shaped the region hundreds of millions of years ago. For a long time, the prevailing idea was that the highlands were simply part of old mountain-building events, pushed up and fractured by ancient collisions. What recent studies suggest instead is that magma once forced its way into these formations, cooling into igneous rock that still sits locked in place. Tiny crystals of volcanic origin are the evidence, preserved over geologic timescales despite pressure and erosion. Their distribution across the range implies not just single intrusions, but multiple eruptions. That means popular hiking paths winding through the forests are crossing what survives of an extinct volcanic field. The peaks may not glow or rumble today, but the land records fire and ash from far in the past. New York hides volcanic scars under the canopy of the Hudson Valley. Long Island Sound growing deeper. Fact 21. Long Island Sound may appear steady from the surface, but new 2025 mapping shows the seabed below is shifting in surprising ways. Using high-resolution sonar, researchers found that some valleys along the bottom are growing deeper than ever documented. What once looked like a relatively flat underwater plain is now understood to be a landscape with ridges, troughs, and channels being carved even today. The cause isn't mysterious. It comes down to stronger tidal currents and erosion. As storms deliver heavier pulses of water, powerful flows scour away sediments that collected over thousands of years. Instead of filling gaps, the currents pull material out of them, deepening valleys and creating sharper relief. Over time, these channels act like unmarked rivers under the surface, constantly adjusting the depth profile of the sound. This reshaping doesn't stay hidden. Changes in depth alter how fish use the water. Shallow zones once filled with shellfish now transition to deeper habitats, and species move with them. For communities along both New York and Connecticut shores, the fishing grounds they depend on are already shifting. Local industries have started adapting gear and adjusting routes, but the message is the same. The sound isn't static, it's redrawing itself beneath the waves. Ice Age ghosts emerging. Fact 20. The last ice age never really left New York, it just went underground. In 2025, fresh discoveries are proving how much of that frozen past is still hidden, waiting for erosion or construction to bring it back into sight. Retreating soils and ongoing development cuts are exposing massive glacial erratics and preserved fossils that had rested for thousands of years beneath layers of sediment. Glacial erratics are giant boulders dropped by retreating glaciers tens of thousands of years ago. Some of the latest finds rest in farmland fields where plows only recently scraped away the surface. These boulders don't match the local bedrock, confirming they were carried here from distant regions on sheets of ice and dropped like forgotten cargo when the glaciers melted. Their sudden appearance tells researchers exactly how far these glaciers once stretched. Plant matter is surfacing too. Layers of soil pulled back by erosion reveal remains of ancient vegetation sealed in oxygen-poor conditions since the Ice Age. Frozen or compressed seeds, logs, and roots have been uncovered intact, giving scientists living records of what once grew here. Dozens of these sites are now documented across the state, each one a snapshot of a vanished ecosystem. Piece by piece, New York is unlocking time capsules left behind by glaciers, reminding us that Ice Age history is still unfolding in plain sight. Cave systems expanding. Fact 19. New York may be famous for mountains and rivers, but beneath the surface lies an often overlooked feature: its expanding cave systems. Updated surveys in 2025 have revealed that these networks are larger than what researchers ever recorded in the 20th century. Using modern imaging tools, scientists now see channels stretching much deeper and farther than the early maps suggested. These aren't just cracks in rock, but extensive corridors winding for miles in darkness. Most of these findings come from limestone regions, where water has been carving pathways for millions of years. The process is slow but persistent. Rainwater seeps through, weakens the stone, and gradually expands into caverns. What earlier explorers thought were dead ends are now shown to connect into larger underground waterways. Some passages weave beneath farmland, while others stretch under protected forests and state preserves. In total, entire miles of cave remain waiting to be charted. The scale is surprising. Specialists working with current data estimate that only half the actual mileage of New York's cave systems is documented. That means what is currently on paper might represent just a fraction of the whole. In 2025, beneath homes, fields, and parks lies a shadow geography still unmapped, larger than anyone realized. Champlain Valley's hidden formation. Fact 18. The Champlain Valley seems straightforward at first glance, wide farmland bordered by mountains and filled with a massive lake. But studies completed in 2025 prove it has one of the most unusual origins in North America. Most valleys in this region can be traced to glacial scouring, when ice sheets carved out troughs and left behind broad plains. That did happen here, but new rock evidence shows the Champlain Valley is not just glacial. It is also the scar of an older tectonic split, where sections of the Earth's crust pulled apart long before the last ice age.